good morning, everybody. Welcome to yet another Zoom session of the virtual tour. And today we begin with Faculty of Technology. We have Professor Dhara with us, who is going to give a quick walkthrough of the particular program that she's going to be talking about. And I'm hoping and having a few students on board as well who are going to be talking about their projects. Dhara, you could begin.
Good morning, everyone. So here we go with our winter exhibition. But before we go for the presentations of the students which they have gone through in their monsoon semester, I would like to brief you about the program. Structural Engineering Design Program, itself, was conceived in 1996 with an aim of providing students with sound principles of structures and their application in the real world design problems. Now, with a unique blend of theory and practice, the course offers unparalleled excellence through the rich array of courses designed by core faculty members and practicing professionals. Starting from elemental level design to system level design, along with detailing of structures, our students are exposed to this rigorous study, models, discussions, and problem-solving approaches, incorporating national and international standards. Students are trained to be professionals as the projects assigned to them simulate office-like situations where each student takes ownership of his or her project. The state of art and creativity in design projects are excelled through periodical reviews by architects and structural engineers, which adds to deeper understanding of interconnection of both disciplines. Now, SEP University provides a nurturing environment to the students to learn new skills and gain practical experience, giving access to latest software and workshop along with multidisciplinary learning opportunities. As we all know, that structural engineering is a very vast field. The program creates a whole range of opportunity to plan their future career in bridges, marine structures, heavy duty steel structures, residential and commercial buildings, maybe steel or RCC. So students also choose to remain in academics and pursue further research. And with the combination of sound analytical background and practical approach, each student of this course is well equipped with the required professional skills and can be the finest choice of any design office. Basically, the MTech program in structural engineering design has a duration of about 2 years, and it is a pioneering program that offers studio pedagogy, wherein live projects under various categories are solved, designed, and detailed by students under the guidance of faculty members. The range of structures designed by students include low and high-rise residential buildings, commercial buildings, industrial buildings, bridges, water tanks, heavy-duty structures, and within that industrial structures, we might have some special structures like chimneys, silos, as far as port structures are also being incorporated. And the program faculty comprises of highly educated core faculty members as well as eminent visiting faculty members. Now, the exhibition which has been there over here is the studio work which the students of first semester and the third semester have gone through in the monsoon 2020. Let me just brief out the objective of these two studios. Starting from the semester one, studio one has been aiming to provide the students with knowledge and skills to design basically industrial steel structures with the latest Indian Standard Code of Practice for general construction. Students apply their own knowledge from strength of materials and structural analysis for further understanding between analysis, selection, and design of structural steel elements and their connections. So basically, the project is being given in a group of 2, wherein the students are supposed to go read the architectural drawings, prepare the structural system, and then they calculate the loads which are going on to those industrial buildings, and then load combination analysis design, as well as preparing the structural drawings, I mean the fabrication drawings, which are going to speak on their behalf onto the site. So the first semester is basically dedicated to design of industrial structures, and a few of the projects also included gantry girders. And so let us begin with the student Anubhav. Anubhav, are you there?
Yes, ma'am. Good morning.
Yeah, you can share. Anubhav is from first semester who has gone through Studio One. So he will be presenting what they have gone through in the Studio One
Sir,
course
yes. Sir,
during monsoon.
my
Yes.
project is design of maze warehouse. If you can, Anubhav Lakra. Uh, There, sir. Yes. Oh. Yes, sir. Sir, can you slide down a bit? Yes. Good morning, everyone. We are here to present our work done in Studio One. Me, alongside my partner Aryan, were assigned to design a maze warehouse, and during the course of our project, we were guided by Dhara ma'am and Rushikesh sir and our TA Poojan Patel. So we were assigned to design a maze warehouse at location Ahmedabad, and we have been provided the architectural plan of 20 by 100 meter for the same. Sir, can you slide down? Yeah. So our location was Ahmedabad and seismic zone accordingly is 3 and wind speed was 39 meter per second. So as per the architectural plan, while preparing the structural layout, first we needed to carry out the structural layout for the same. We needed to keep in mind various critical openings such as door at the gable ends, shutters and windows. So accordingly, we have placed the columns and provided them at equal distance, that is 7.08 from grids and 7.114 at the gable end. So for the same here, we have shown our central line plan uh, at the level, at the base level, at the eave level, where we have tie beams for connecting various portal frames and bracing and purling position at roof and gable end. Sir, can you slide down? Yeah. So we can see here the our center line plan at base level, at eave level, and sir, can you slide now? Yes, and bracing and purling position in the plan accordingly. So now, yes, next slide. So now we were asked to make some changes from our provided architectural plan. So we went for truss rather than a portal frame. Basically the main reason was, as we can see that for a normal portal frame girder, when it is subjected to a load, it experiences maximum flexural stress at the ends. We can see that in the figure over there in the diagram. However, in truss, all its elements take up either tension or compression, and hence its axial stress distribution is uniform, which can be seen over here. So all members act as a winning team, and so therefore we have opted for truss. Also, truss is lighter as compared to a portal, hence it would be economical for larger spans, as in case of our project. So yes. So next slide, please. Further, we needed to calculate dead load and live load and wind load. So we have taken self-weight of GI sheet used in our project from Tata Shakti and calculated the same. And for live load, we have used IS 875 part 2 and calculated the same. And these we have depicted them in our STAD model also, which can be seen over here. Next, we have calculated our wind load as per IS 875 part 3. All the factors are considered as per the IS standards, and we have depicted the wind load distribution on wall as well as, yes, slide. Yes. So and on the roof similarly, and there are the load combinations shown on the right side, which have been used in our structure. Then the design philosophy. Basically, we have designed our column as per IS 800 2007 section 9 and bracing and truss members using IS 800 section 6 and 7. Basically, the columns are designed using for combined compression, tension, and bending, wherein bracing and truss members are designed as compression or tension member depending upon whichever force is higher and checked for the remaining force. We have used ISWB 250 for the column and two star double angle 6066 for bracing, and yes, and all the connections are shear connections and are designed as per section 10 IS 800. Yes, sir. Please slide down. Yes, then here we can see how we have designed our truss connections. So we have used column plate and shoe plate to design our column and truss. Yes. So our columns, as we can see, was IS8, ISWB 250, and column plate accordingly came out as 340 by 314 mm. So we can see one of the type of connection over here. And then beam to column connections were also designed as shear connections, and the bracing connection for wall as well as elevation bracing were also designed accordingly. The cleat angle used in beam to column connection was ISA 7078 was required. Lastly, base plate connection. So the base plate, basically its philosophy depends upon firstly we have to assume the area of the base plate, which is assumed accordingly to the size of the column and the dimension of the base plate, and thickness of the base plate is also assumed, and it is also checked with Rook's adequacy formula adequacy. And thickness depends upon the intensity of the pressure of on the plate. And as we have a column of ISWB to 250, for which we get the reactions from STAT which have been depicted over here, and accordingly we have designed our base plate also. So yes, thank you. Thank you.
Thank you, Anubhav. That was really nice.
Yes.
Dhara, we have another student, or would you like to take it
Yes.
forward with a couple of more projects?
Yeah, we have one more student from third semester. This was regarding the first semester. Now the third semester students are, just a minute. The third semester students are having heavy duty structures and some special structures like bunkers and silos in their studio 3, which they are supposed to analyze, design and detail. So we have a student from third semester who is Dhruv Patel. Dhruv, can you hear me?
Yes, ma'am.
Yeah, can you just start with your presentation? Just guide Hemant.
Design of industrial structures. Dhruv Patel. It's in third row, I think. Go down.
What's the name?
Dhruv Patel. Yeah, it's second row here. This one. Yeah, you can slide down. Good morning, everyone. Myself, Dhruv Patel. I'm from Masters in Structural Engineering Design. I'm in fourth semester. I will be in fourth semester. In third semester, we were assigned with 3 different projects. So first project is a silo project, then chimney and industrial steel structure. So for silo project, please slide down. For silo project, I was assigned with a battery of 4 silos in a square pattern. So these are the configurations of the silo: 14 meter in diameter and 49 meter in height. And these are the pressure calculations manually done. And you can slide down. After calculating pressure was applied in the STAD model, and different load cases were generated, like one silo full, 2 silo full, all silos empty. And based on that, based on STAD result, silo walls were designed based on stresses obtained from the STAD model. Silo walls were designed. Similarly, silo cone was designed for all silo full case, so it will take care of all the load combinations. So this is slide down a little bit. This is ring beam design. So ring beam design was done for hook compression and the torsional moment. So for that, all the steel and reinforcement was calculated, and this is detailing of the silo project. So you can go down. For chimney project, we were given chimney height and location of the chimney. And based on the comparative analysis, we decided which chimney is better for the construction and which chimney is economical. So for my case, it was tapered chimney, which was economical to construct rather than straight chimney. This is comparative analysis between straight and tapered chimney. Go down. So after analyzing chimney manually, we designed a chimney for a wind and earthquake. So based on the wind moment and earthquake moment, chimney walls, chimney shaft was designed, and it was detailed accordingly. This is a chimney section at various location. So it is wide at bottom and it is going narrow at top. So this is the chimney raft. Chimney raft was also designed manually. So based on the moments obtained from wind and earthquake calculations, chimney raft was designed and detailed accordingly. You can go down. So for industrial structure, I was assigned a cement mill project. So for cement mill, it is very necessary to give larger spans. So challenging part about this project is very large span. So there were 13-meter by 15-meter span, 11-meter by 15-meter span, different kind of span. So working with larger span means you will have to control deflection, and loading is quite high because all the industrial structures are quite heavily loaded. You can go down. So these are floor plans of various levels, and based on that, structural system was decided, and plant bracing was provided to take care of rigid diaphragm, because this plant contains plant has checkered plate as a flooring system, so it does not provide a rigid floor diaphragm. You can go down. So based on that, STAD models were prepared and design of all the members were done in STAD, and it was checked manually, and based on the detailing was done. These are base plate detail, connection detail and all that, and this is elevation, how the bracings are provided in elevation. Yeah, that's all. Thank you.
Thank you very much, Dhruv. So I hope everyone has got an overview of what the students from Studio 1 and Studio 3 have done in their semesters. Yeah, that's all, Kinjal.
Thank you, Dara. Thank you, students. Thank you, professors who also
Yeah,
joined
thanks
me.
all of you. Dhruv, Anubhav, yeah, thanks a lot for your presentation.
We would definitely request everybody on board to share this exhibition website, share your projects to other people, to your friends, to your family members,
Yes,
to
yes.
everybody you know from the industry, because it's time for you to share your work, which you've put in with so much of time and effort on campus or off campus, online predominantly. So go ahead, share, and let us also know how the things have been for you. Thank you for joining in today.
Definitely. Yeah.
Bye-bye. Take care.
Yeah, bye. Yeah.
Yeah, unmute.
Yeah, I'm also ending the meeting, okay? Hello, Hema.